Prehistoric men discovered that some metals were more appropriate when it came to doing certain jobs, and they began to specify particular metals for applications. For example, gold and silver are very soft and were predominantly used for decoration and bullion for trade. Copper offered prehistoric men more qualities and could be hardened by hammering or forging, and was therefore used to make primitive tools. The discovery of bronze, which is an alloy of copper and tin, changed the way that men lived, hunted, and fought. It was stronger than copper, could be hardened by forging, and could be cast to a specific shape. Lead is soft, easily worked, and prehistoric men realized that it was perfect for making into vessels to transport liquids. Iron was a game changer. It was such an important material used for all sorts of applications, and the phenomenal growth of its use led to the Iron Age, a transition from the less developed Bronze Age. Today, our society is completely reliant on metals, often far removed and much more exotic than the wrought copper first discovered thousands of years ago. So with that thought, let us introduce you to the chapter Metals and Non-Metals. Hello students, a very warm welcome to Notebook. The chapter Metals and Non-Metals has been divided into 8 parts so that you get a clear understanding of it, and today we shall discuss the physical properties of metals. So before we dive headfirst into the chapter, we should recapitulate what elements are. Elements are pure substances which consist of only one type of atom, and based on their properties, we can classify elements into metals, non-metals, and metalloids. Metals are those elements which form positive ions by losing electrons, and their examples include copper, iron, aluminium, etc., while non-metals are the exact opposite and they form negative ions by gaining electrons. Examples of non-metals range from oxygen, sulfur, iodine, etc. Metalloids, on the other hand, are elements that show properties of both metals and non-metals. These include boron, germanium, silicon, etc. So today, we shall learn about the different properties of metals and shall start with their physical properties. The first physical property of metals are that they have a luster. Metals in their pure state have a bright shining surface. This property is called metallic luster. Think about gold and silver ornaments. Have you seen how shiny most of them are? Do you know why this shine occurs? This is because of the electrons which are present farthest from the nucleus of the metal atom. These outermost electrons reflect light, thereby providing the metal a glittering appearance. The second property that metals show is their hardness. Most metals are significantly hard. For example, it is impossible to break an iron block with your hands, but on the other hand, some metals are comparatively softer, such as potassium, which can be easily cut by a knife. The atoms of metals are actually bonded by strong metallic bonds, and this imparts the hardness to most metals. The third property that we shall be discussing about is their ductility. To understand this, let us see an example of this. When ornaments are made, chunks of gold are actually passed through narrow holes so that they can be drawn into thin wires. These wires of gold are then used to make different patterns of gold ornaments. Similar to gold, copper can also be drawn into thin wires, which we often come across in all electrical appliances. This ability of metals to be drawn into wires is known as ductility. The fourth physical property of metals is their malleability. Most of the metals are malleable, which means they can be beaten into thin sheets. This happens in iron factories, where iron is beaten into thin sheets for easy storage and transportation, and for use in different purposes such as in the construction of furniture or even bodies of vehicles and aircrafts. The fifth property of metals is their ability to conduct electricity. If you remember from our previous example, copper is the number one choice while making electrical wires. Do you know why? This is because copper is a very good conductor of electricity. But conductivity varies from one metal to another. A metal by the name tungsten has been found out to be a poor conductor of electricity. But have you wondered how is the electricity conducted in metals? It is due to the presence of free electrons present in metals, which can readily carry the electrical charge and move along the conductor. Students, after electrical conductivity comes our sixth physical property, which states that most metals except lead are good conductors of heat. So what happens when we touch a hot pan by mistake? We immediately remove our hand because of how hot it is, right? But do you realize that the pan was only exposed to the flame at its bottom? So how does its body become so hot? This happens because of the phenomenon called conduction and is again attributed to the fact that metals have free electrons. These electrons can move around and collide with other atoms of the metal and transfer the heat. As a result, the entire pan becomes hot. The next property of metals are their generally high melting and boiling points. Well, most metals have a very high melting and boiling point, and tungsten has the highest of them all. Whereas metals like gallium and cesium have very low melting points and can even melt if we leave them on our palms. The last physical property is their sonority. Most metals have the ability to produce a ringing sound when struck. This property makes most of them highly sonorous. All of us have seen how bells ring, be it in temples or in some other places. Even school bells and doorbells are made using this property of metals. So students, you see how metals have their unique sets of physical properties. You will also be amazed to know that mercury is the only metal that exists as a liquid at room temperature. So with this, we come to the end of our today's discussion on the physical properties of metals. In our next video, we shall talk about the chemical properties of metals. Until then, take care and goodbye.